we are asked to use synthetic division to find the zeros, and we're at the second level here. They're giving us a cubic polynomial, and it's in descending order with no parts of it being skipped. They're telling us that it has a solution here. When we plug in -5 into our function, we get a 0. That's part of the remainder theorem. And then we're asked to find all of the zeros of f of x algebraically. Well, we found a 0 already. One of the zeros is -5, but let's remind ourselves, zeros are also called roots, solutions, or x-intercepts. Okay, so that means that if -5 is a solution, a 0, a root, or an x-intercept, that this means from the remainder theorem that x plus 5 is one of the factors of this polynomial. So we're going to use that fact to divide this polynomial by x plus 5, and then we'll look at what's remaining and deal with it using factoring or the quadratic formula. All right, so they want us to use synthetic division in here, so let's go ahead and do that. So we would say x plus 5, and it's dividing into 5x cubed plus to 12x squared minus 59x plus 30. Now I know x plus 5 goes into this evenly because the root of -5 gives us an output of 0 when we plug it into the function. That's the remainder theorem. So we're going to go ahead and use synthetic division. Now, just as a note, I prefer long division because I remember it easier, and this one is strictly having to do with a process, which is easy to forget. So beside that point, let's go ahead and just do it because that's what we want. So that means I'm going to use the root here of -5, and we start off by bringing the coefficient of the leading term straight down, and 5 right here. Now the process starts. -5 times 5 is -25. And I can bring all these constants down, just looking at our coefficients, and that's a -25. 12 minus 25 is -13. -5 times -13 is a positive 5065. Add straight down, and that gives us a positive 6. -5 times positive 6 is -30, and it had to equal 0 because of the remainder theorem here. Now this is our constant term, this is our x term, and this is our x squared term. So that means this polynomial right here turns into and is equal to x plus 5 times 5x squared minus 13x plus 6. Okay, now we can factor this or use the quadratic formula. Quadratic formula works every time, and it gives you the complex answers. So I don't know if this has complex answers or not, but if it doesn't factor, then yes, it would have to have complex answers. But I'm going to try factoring just to help us practice. I'll use the method we use here at our school, which is the box method. In the box method, we put the x squared term at the top left. We put the constant at the bottom right. We use a diamond problem to find what these two numbers are. The multiplied number is 5x squared, so 5x, I don't like that blending in like that, 5x squared times the 6. That's going to give us 30x squared. What two numbers multiply to be 30x squared and add to be the middle number here, -13x. Now, just as a note, you can keep the x and the x squared and focus on the numbers, and then just make sure you include the x here. It has to have an x. Or keep the x's, and if you're not distracted by it, it'll get you the right answer that way also. All right, so what two numbers multiply to be 30, add to be negative 13? I get negative 3x and negative 10x. These two numbers multiply to be positive 30x squared and add to be negative 13x. It doesn't matter the order at which you put them in here. So I'll just go ahead and put the negative 3 here and the negative 10 here. Then we're looking for filling in these spots. What do they have in common, vertically and horizontally? I always like starting right here at this spot here. So what does 5x squared and negative 10x have in common? They both have a 5x in common. And then everything else unfolds. 5x times what is 5x squared? 5x times x. X times what is negative 3x? Negative 3. 5x times what is negative 10x? Negative 2. And then confirm, does negative 2 times negative 3 make positive 6? And yes, it does. So that means now this turns into, we still have the x plus 5 in front, times, and these are the two factors here, 5x minus 3 and x minus 2. So it does factor. That means your other two solutions are going to be real solutions. So this is basically the zero product property now. When are each of these equal to 0? Well, we have the negative 5 already. Check. That's this one. Then we would say 5x minus 3 equals 0. And x minus 2 equals 0. Each of these components, each of these factors have to be equal to 0, and then we'd see where that happens at. This one's pretty easy, and a lot of us, we can recognize that. If there's nothing in front, we can clearly see it's just the opposite of negative 2 of positive 2 is the other factor. And then this one, just be really careful about doing it in your head. I know a lot of times students want to take a shortcut here, but it's really recommended that you just go through the process of multiplying or, solving it to be sure you don't make any mistakes. So add 3, 5x equals 3, divide by 5, x equals 3/5. So I have three solutions, a negative 5, a 3/5, and a 2. Now, I really recommend that you do these in order. So negative 5 comes first. So this is the set. These are the solutions, negative 5. Then 3/5 would come next in order. And then 2 lastly. So those are our zeros, our solutions, our x-intercepts, or our roots. All of those, I encourage you to practice that vocabulary. So negative 5, comma, 3 divided by 5, comma, and 2. And we got it. All right, so there you, and like we said, use synthetic division, then factor this if you know how to factor, and then they show you the quadratic formula. That would be if it doesn't factor, or you can always use it. But notice how long the quadratic formula is compared to factoring. So factoring is a much more powerful, well, I don't know about powerful, but it's a more streamlined tool to kind of get you through it if it factors evenly. Okay, let's take a look at the next one. Actually, let's go ahead and look at a different problem type. One real, two non-real. Okay, let's look at the non-real solutions. All right. There we go. All right. So same, okay, it's set up a little bit differently. So they want us to use synthetic division to find the zeros. They're giving us an x cubed equation in descending order with nothing missing. They're telling us that x minus 1 is a factor of f of x. Then find all of the zeros of f of x algebraically. All right. Well, first off, we know that x equals 1 is going to be one of the zeros. So just practicing our remainder theorem, if I plugged in 1 into this function, it would have to give us 0. That's kind of what it was saying in the last problem. But they're just telling us it's a factor, so we'll go ahead and use that. And I'll go ahead and use it with synthetic division since that's their focus. So we have the x minus 1 is going into x cubed plus 5x squared plus 4x minus 10. This has a coefficient of 1, 5, 4, and negative 10. And like I said, I really prefer long division, but that's fine. We look at the root when we start off here. So the root, instead of, we wouldn't use a negative one, we'd use a positive one. All right. Then the process starts off with, we multiply these two together, and then that answer goes right here. So 1 times 1 is 1. Then we add straight down, we get 6. 1 times 6 is 6. Well, I like that one already. 4 plus 6 is 10. 1 times 10 is 10. And then you have to get 0 here. That's the way it was designed. This is the constant term. This is the x term. This is the x squared term. So that means all of this turns into, is equal to the x minus 1 factor. They told us that. And then we just solved it using synthetic division. The remaining, that would be x squared plus 6x plus 10. All right. So this one's a little bit easier. We always want to check to see if it factors. If it doesn't factor, then we have to use the quadratic formula. All right. And especially if there's a 1 in front here, that's pretty easy. So what two numbers multiply to be 10, add to be 6? Well, does 1 and 10 in any way make 6? Nope. 2 and 5 in any way make 6? Nope. And those are the only factors of 10, so I know we have to use the quadratic formula. So this is ax squared plus bx plus c. So c is 10, b is 6, and a is 1. All right. Always rewrite your formula. The quadratic formula is x is equal to plus or minus the square root of b. See, that is not the quadratic formula. X is equal to, oh, gee, did I just forget the quadratic formula? Oh my gosh. What's happening to your math teacher? Brain is getting fried. B squared minus 4ac all, no, that's the discriminant. Negative b, I forget. Darn it, I forgot. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, you should have this in your notes. I just want to be sure. I hate to do this. So quadratic formula. Always try from your brain first, and then just, oh, there it is right there. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, all right, good. And always try to do it from memory first, and then check it with a reliable source to make sure you've done it right. Okay, so I got it right. Good thing. Got a little worried there for a second. Plugging all our parts in, negative b is 6 plus or minus the square root. B squared is 6 squared minus 4. A is 1. C is 10. And all of this is over 2 times A, which is 1. All right, simplifying. X is equal to negative 6 plus or minus square root of 36 minus 40 all over 2. That tells us that x is equal to negative 6 plus or minus the square root of negative 4 all over 2. And the square root of any negative number comes out as an I, and the square root of 4 is 2. So this now becomes x is equal to negative 6. I'm just going to start dividing it by 2 right now. Plus or minus square root. Oh, I don't know. Just did that. 2i. Square root of negative 4 is 2i all over 2. Dividing it out. X equals negative 3 plus or minus I. So that gives us two answers. That x is equal to -3 plus I and -3 minus I. And then we also have the original of the answer is x equals 1. All right. So those are all of our roots, zeros, solutions, or x-intercepts. I'm not really sure you can call these complex answers x-intercepts, but just kind of practicing with the vocabulary here. All right. So I would always start with the real solution first. So 1, comma, then we got -3 plus I, comma, and -3 minus I. And everything looks good. Okay. Got it. So let's see how they did it. Synthetic division, just like I did. Factored it out. Used the quadratic formula here. I like testing to see if this factors. Plugging everything in. All the steps were pretty much the same and got it. Okay. So all your problems are going to be very similar to these two.